it's on a frictionless surface. So we don't lose energy to external forces like friction in this case, okay? So what do? We call that 0 if everything's at rest, not moving at all. If we grab this thing and we pull it to a distance of positive a away from 0, and we let go, it will oscillate back and forth between plus a and minus a. Remember?
No, I
It
don't.
seems like an eternity ago. It was actually only a few days, right?
Yeah.
And we said, if this is the x-axis, I can determine the location or the position of the mass by this function, a. We started with cosine in the discussion, right? A cos omega t. You guys remember that? No?
Yes.
Yes? James? And then we said, well, if I, in a calculus sense, take the derivative of this thing, I can come up with an expression for its speed. We don't know calculus, so I'll just give you the result. It says the velocity of the object at time t is minus a omega sine omega t, where this is the amplitude of the velocity, the maximum velocity over the entire cycle. And then we went further, and we took the derivative, or we said you don't have to know how we got to these equations. You do need to understand what these equations will tell you. Okay? You guys remember this? So when we have the test on this, I'll tell you what to expect. I always ask a problem where I give you one of these, usually this one, and I say, or actually, I say, what's the amplitude, what's the frequency, what's the angular frequency, etc. And I ask you all kinds of questions about the waveform, the sinusoidal function, okay? The period, all those kinds of things. And we'll go over that when we get there, but these are the takeaways for this problem. Now, in the lab you did on Friday, you did simple harmonic motion of a mass hanging vertically. Okay. Yes? Well, because gravity is in the picture, it doesn't change these equations. All it simply does is change where my 0 point is. If I hang a mass and I leave it alone, it just changes my equilibrium value to some lower location. And then if I ping it, I grab it and let it oscillate, it's still the same set of equations to describe where it is, how fast it's going, and its acceleration. It can be shown that it makes no difference. It just changes the starting t0 point if I hang it vertically. Okay? These are still applicable. So that was the gist of chapter 10. So now we're going to move on to something called fluids. There are two pieces of fluids. The first one we're going to talk about are fluids that are not moving, static fluids. Not moving. So just think of a swimming pool, and you go and you're floating on top, and then you dive to the lower down in the pool. Okay, the water's not moving. What can we say about the water and the pressure and the density and all those kinds of things? Okay. Later on, we'll talk about water that flows, as in a river, and those sorts of things. But for today, it's just static fluids.